everybody, MoNaCo here.
And milks.
We are still in moles and stoichiometry. We're doing a little another percent composition today, but we're doing percent composition for hydrates, I think, right?
Yeah.
Page 19.
Yeah. Calculate percent composition. We can put in hydrates. Should we fix it?
Nah, it's fine.
All right, we're gonna roll it. Here we go.
So, what is a hydrate, Mr. Mills?
A hydrate is basically, in this case, it's one of these inorganic molecules with water infused into it.
Right. I like to think of hydrates as compounds that are like a dry sponge from the store. You open the sponge from the store, and it's dry. It's crusty, it's crunchy, it's light, and it soaks up water.
Right.
Hydrates are compounds that come with water molecules attracted to them. They soak them up. But you know you can dry out a sponge, right?
Right.
Well, you can dry out a hydrate too.
Right.
And so, because you can dry it out, you get to this point where we should know how much percentage of that compound is due to the water.
Right.
So that's what we're going to do today.
Let's figure out a name them real quick, just in case we have to do it, and then otherwise we'll get right on the percentages.
Nomenclature. Okay.
Nomenclature. So, first thing we're gonna do, we're gonna name the compound.
Which are always going to be probably polyatomic compounds.
Yeah. Well, and in this case, at least ionic.
Definitely ionic. I've
For our
never
case of
seen a
purposes.
covalent one that is a hydrate.
Well, technically, the word hydrate does go into organic compounds because technically glucose is a hydrate. It technically has water in it. It has H2O. A carbohydrate has water in it with the carbon. It's carbon and water.
The hydrate, yeah. Well, we could argue about that another time. But for this lesson,
Yeah, it's only in the name, carbohydrate. But okay, you're right. You're right. Because anyway, so name this CuSO4 for me. Remember how to do that?
Yep. The metal says its name is copper,
Okay.
and SO4 is a polyatomic ion, so it says its name, which is sulfate. Now
Beautiful.
the thing is I got to figure out if it needs a middle name. So sulfate I know is a -2,
Right.
and the ratio of copper metal to sulfate polyatomic ion is 1:1. So the copper must be +2. So I'm going to say the name for this compound is copper, Roman numeral 2 in parentheses, sulfate.
You're really good at this.
Yeah.
You know, if you ever need another gig, you should be a chemistry teacher.
Yeah.
Yeah. There you go.
Now
Copper
work out.
2 sulfate. Great.
But we're not done.
We aren't, because what about this hydrate piece?
That is not multiplication, is it? That's a dot.
No, it is a dot.
It means to complex with.
Yeah, well, in a way, if you were to think of it as a multiplication symbol, which we do not do when we do percent comp,
We're not.
every one molecule of copper sulfate, I have
5 molecules of water.
So if we're going to talk about it as multiplication, we're going to do it that way.
Or if we could talk about it as a complex, I'd say 5 water molecules are complexed with
There you go.
1 copper sulfate formula.
Okay. So what we're going to do to take care of this hydrate thing is we're going to just add the word hydrate, and we're going to put a prefix in front of it with our normal prefix rules to tell me how many hydrates.
So like mono, di, tri, tetra.
All those same prefixes we learned earlier.
Okay.
Yep.
So this would be 5 H2O, so mono, di, tri, tetra,
Penta,
hydrate.
done.
Okay.
Copper 2 sulfate, pentahydrate.
Another way thing to think about hydrates is like, when you don't drink enough water, you get dehydrated.
There you go.
So you must hydrate yourself by adding more water into you.
There you go.
So these molecules have added water into them, which can be driven away. Yeah.
Yes.
So when we do calculate percent composition of water in a hydrate,
This is going to go just like we did percent composition of any element
In a
within
compound.
bond. Right.
except that we're talking about only the H2Os in this scenario.
Generally, yeah.
Yeah.
If we're dealing with hydrates, we want to know about the water.
So always first step is find the gram formula mass
Yep.
of the compound.
Right. And the special note here is we add the 5 waters on, we don't multiply them.
Right.
Got to
Or
know that.
If it's 2 waters, we'll add 2 waters.
Sure. Because
Right,
this
5.
case is 5, we got 5. So, okay, so we add the waters on. We don't multiply because there's a dot.
So in a way, there's really 2 gram formula masses to do. 1 for the copper sulfate
Yep.
and 1 for the H2O.
Correct.
And then in this scenario, we'll add 5 waters onto whatever we got the sulfates from.
Sure.
And we'll see what it all works out to be.
Right.
I think we should probably practice.
Yeah, well, I mean, to be honest with you, what I would do is, if I were to just talk my way through it, I would do my copper like normal.
Mm-hmm.
I would do my sulfur like normal. I would do my oxygen 16 times 4. Then I would write water,
H2O.
H2O, and its gram formula mass is 18.
Because that's one that's really
And then
easy to do.
times 5, because I got 5 of them, and then just add them all up.
Well, you'll do one and I'll do one and we'll work it through.
Sweet.
Sounds great.
So, and then of course, we're going to do, the next part is
Percent.
part over whole, which is the same deal. And in this case now, the part is just going to be the water.
Right.
So I
So
think we're on to examples.
let me do this first one, and you can do the
Okay,
second.
fine.
I think we're going to do them the same way.
Pretty
but,
much, yeah.
The first part is always to the gram formula mass. So I have copper, I've got sulfur, I've got oxygen, and here's the twist we're talking about. I've also got H2. Oh yeah! So for copper, I got 1. For sulfur, I got 1. For oxygen, I got 4. And for H2Os, I have 5 whole H2Os. That 5 is what I'm talking about right there. If you did each part out separately, you're doing more work than you really have to.
Sure.
If you do it this way, you're going to get to an answer pretty quickly, and it's going to be right.
Right.
So let's find the masses on these and multiply by. So copper, I think, is 64.
Oh, don't think, Mr.
I
MoNaCo.
should
You
check,
don't know.
I should check.
Straight in front of you.
63.546, so I'll say 64 grams per mole there. Sulfur, I know that one's 32. Oxygen, I know that one's 16. And here is the rub, water.
18.
18 grams per mole. That's the gram formula mass for water. So you can just go 18 right there. Boom. Do our multiplications.
Right. That 18 is a 16 plus 2 hydrogens. So that's
Well, I got 64 easy. I got 32 easy. I got 64 again. Wow. 18 times 5 is the same as 9 times 10. That's 90. Right? Did I do it right, Mr. Milks? You checking it with a calculator?
Oh, I was just adding them all up and going with what you had.
Uh-oh.
Oh, I can do it though. 5 times 18 is 90. You good?
Yes. Okay.
Plus 64.
Let me see if I get 128, 30,
Plus 32.
158,
Plus
100
64.
and 248.
Yeah, 50.
Oh, I was off by 2.
Yeah, 4 and 4 is 8. Plus 2 is 10. So
Oh, I forgot that too. Bummer.
it's all right.
See, mental math can be faster than a calculator.
And it can be just as accurate.
Almost as accurate. That was pretty good.
Oh, you're good. You're good.
If you look at my percent error
Oh, here we go.
by the
So-
part divided by the whole,
Come on, let's
I'm
try and keep
pretty
this
darn
video-
close.
let's try and keep
I'm
this
getting
video
real close.
short.
Here. So now we got to do the percent water. That percent that was H2O in here is going to be the part that was water, 90. This right there.
There you go.
And so we got 90 divided by the 250 times 100 equals the percent by mass of H2O in this particular compound. I want to see you actually do that. Yeah,
36.
about 36% is your final answer. Let's see if Mr. Milks can get it done any faster than that.
Ooh, well, I don't know about faster, but anyways.
Better, maybe?
No, not at all. And I just wanted to put a little highlight here. Because we kept this water together, throwing that part 90 up into your calculation was lickety-split.
Yeah.
We were able to do that real fast because we did it this way. So you'll just have to believe us when we say you should do it exactly the way we're getting you to do it. So I'm going to calculate my gram formula mass. I got calcium, and I've got chlorine, and I've got water, right? And calcium's mass is 40, and I have 1 of them. Chlorine's mass is 35, but I have 2 of those, so that's a total mass of 70. And then water, we did this a minute ago, is 18, and I have 2 of those, so that's 36. So we're going to add this all up, and I get 146 grams per mole. How's that?
Solid. That was very fast mental order.
Sweet.
Sir.
Well, I had a lot of zeros, so that helps.
Mm-hmm.
It really does. So now I'm on to part 2. I'm going to get my percent water, and I'm going to take this 36 as my water and bring them right over. It's my part, and I calculate my whole to be 146. I'm going to multiply times 100.
Oh, you want me to do that? 36? You mean you can't do that in your mind, sir? No.
Well, we want the video to end before too long.
Silly fingers on the calculator. 36 divided by a sine 146 times 100. About 24.6, so about 25%?
25% water in this particular hydrate.
And the reason why we've got to be able to do this is because when we do a lab, you're going to drive the water out of a compound,
Cook it right off.
cook it off, and you're going to tell us what percent the compound was H2O
Right.
compared to what it should have been
Sure.
to see how close and accurate you
And
are.
this is actually really going to be really similar to how we find out how much sugar is in a piece of gum.
Yes, it is.
Right.
Except there's no cooking, there's chewing.
Right. So there we go.
So calculate percent composition of water in hydrates. Remember, water has a gram formula mass of 18 grams per mole.
That's a good one.
Work smart, not hard,
Yep.
and don't break it up. So, do the gram formula mass for the formula compound, the ionic, and then tag on however many H2Os you have.
It'll make it faster.
It makes it so much better.
Right. So
And
again,
part divided by whole, E times 100 is percent, no matter what you count.
there you go.
Okay, so thank you for watching.
See you guys.
See ya.